Actually, now I have a chance to answer on your question, what is the bioconvergence? I'm also asked ChatGPT, and the diversity of answers I have received, I decided to define my own definition. Actually, for my understanding, bioconvergence is a mega trend. It's actually convergence of life sciences, exact sciences, engineering, and computer sciences, and even much more, including AI, machine learning, industrial design, a lot of things. Actually, bioconvergence involves a biology with cutting-edge technologies coming from other areas to solve complex problems in areas such as healthcare, agriculture, energy, etc. So my understanding was that HIT can be a very, very nice place to develop this field. And I will justify my thoughts. Actually, at HIT, we have a lot of parts of puzzles, especially in the Faculty of Electrical Engineering. We have a communication engineering, we have embedded systems, we have nanotechnologies, we have robotics, we have power systems and renewable energies. And as an HIT, we have also other faculties which can support bioconvergence. Faculty of Exact Sciences with very nice educational program, BSc and MSc in computer sciences, data science, and as Rafi mentioned, the digital technologies in the field of healthcare. But there was one missing part in the puzzle. And the missing part in the puzzle actually, sorry, it's Yuval. Why? Because if you want to develop something unique, you need leaders. And actually, 1 year ago, it was our first meeting, and decision was very, very fast. And actually, Yuval is a part of our faculty, and we are very happy having you. And actually, I want to emphasize that without you, I think that no chance that we can develop this activity and the program. So I will little bit go back. And as you can see, there are a lot of applications of bioconvergence. But if you are looking for the applications, it's not about the proteins or just biological sensors. It's about the systems. If it's artificial heart, robotics prostheses, neural implants, etc., everything is related to the system. So our decision was to develop the MSc program for the electrical engineers. Because finally, what is the main difference between electrical engineers and those coming from the exact scientists? We know how to take the scientific idea and actually how to develop the technology based on this scientific idea and how to develop the product. It's bottom up and also top down. Once we have an understanding of the real problem, we can find the solutions. And in the case we need to involve other disciplines, we can do it. So actually, this is our focus in bioconvergence, to educate electrical engineers, and actually they will lead the developments in the field of bioconvergence in various applications. Okay, so now we have Yuval, but there are some challenges how to merge the bioconvergence and electrical engineering, because actually finally our students, they are engineers. in the field of electronics, they are not they are not physicists, or they are not working in the field of biology. So we have to find the right balance between the electrical engineering and between those skills we have to give to the students in order to lead this field. Integration of technologies is one of the main challenges, and I think that we have found a very nice balance between those skills that required from the bioconvergence perspective and from the electrical engineering. There are also other issues, such as ethical issues and regulatory hurdles, because we as an engineers understand very well the standards from IEEE, but we are not on the daily basis actually working with the constraints from the regulators, etc., related to the healthcare and other areas. So these are actually the main challenges between the converging, the bioconvergence and electrical engineering. And now I will give you the scientific justification and the process. Okay? Actually, I am working in the field of communication theory. In the communication theory, we have the channel capacity. C is the capacity, B is the bandwidth, and actually the capacity of the system depends on the density and on the signal to noise ratio. So if you want reliably communicate over the noisy channel, the capacity of the channel, the amount of information you can transmit, depends on the bandwidth and on the signal to noise ratio. How it is relevant to the bioconvergence? Okay, let's try to find the analogy between the channel capacity and channel capacity for efficient management. B is the budget. Actually, you always have a budget constraints. And if your budget is equal to 0, you have 0 capacity. So we have, first of all, solve the problems with the budget. And fortunately, the administration of the institute, our B is not unlimited, but it's not 0. But actually, it's constrained. Bureaucracy. If you want to establish a new academic program, what you have to do? You have to include the new program in the Tochnit Chomesh, it's 5 years planning. So in average, you have to wait 2 or 3 years before you are submitting the new study program to the Higher Education Council. It will take more 2-3 years for approval of this program. So the latency, in average, is at least 5-6 years. But we have found the solution. If you have existing program, and we have existing program in bioengineering, you can enhance, extend the existing program with the new courses, with the new directions, and in this case, it takes less than 1 week. So we have shortened the latency from 6 years to 1 week. So we know how to manage the budget and bureaucracy. But we can do more. We want to improve the signal to noise ratio. What is S? In my case, S is standing for the staff, students, and skills. If you have strong academic staff, you can increase signal to noise ratio. If you have strong academic staff and students, and they have a lot of skills, including the soft skills, you can increase the capacity, your capability to solve very complicated problems. What is the noise in our case? There are a lot of noise, but you can improve the signal-to-noise ratio by having a clear vision, clear understanding of your mission, focus and priority. Otherwise, you are doing a lot of things, you are increasing the noise, and actually you are decreasing the capacity of the system. Okay, but we can do better. In the communication theory, you can transmit information using the symbols, and each symbol can transmit just 2 levels of information, 0, 1. In this case, spectral efficiency is very low because one symbol is transmitting just 1 bit. How we can do better? You can transmit more complicated words, let's say 0, 0, 0, 1, 1, 1, 1, 0, with the same symbol. So the required bandwidth is the same, but capacity is higher. Okay, so 2 power m, but what is m in our case? It's actually the motivation of the staff, it's a multidisciplinarity of the staff, and actually the ability to doing multitasks. And there is another 1m, but Moti is not here, but Moti Vishan is helping a lot to resolve administrative problems. So yes, you can do better even you have a limited budget, even there are some bureaucracy, but if you are managing your staff in efficient way, you have a vision and mission and you are focused, you can do better. The name of the conference is triple helix. Actually, the previous formula was the detailed description of the Shannon capacity, but at the macro level, the Shannon capacity is a maximum of the mutual information. So if you have a transmitting part and receiving part, if you want to actually estimate the message was transmitted to you, it's mandatory to have some overlap between the entropy of the source and between the entropy of the receiver. This is called the mutual information. So let's change the mutual information to mutual interest. Without having the mutual interest between academy, industry, and government, it is very, very difficult to do big changes. This is the reason that we are collaborating with a lot of industries in Israel and outside. We are working with government, Israel Innovation Council, Mafat, and others. So we are more than sure that this nice combination of all parts actually is the rating hit of the new direction of bioconvergence. Thank you.